Hey guys, Mr. Gucci here with another help video. This time I'm helping you with 12.2, numbers 9 and 11, okay, from this section right here. So let's get to it. First thing you got to do, make sure you put in your student ID. Now let's get to it. So question 9, how much heat energy would be needed to melt 1,402 grams of ice once it has reached its melting point? So this problem, as every problem in this section, is going to be of this new type right here. The energy needed to change something's state of matter, say from solid to liquid or liquid to gas, is equal to the mass of the substance times a heat of phase change. Now, this is a heat that tells you how much energy you need to change something from a solid to a liquid or a liquid to a gas. And every substance has unique values. For example, the heat of fusion is the energy it takes to melt a substance, take it from a solid to a liquid. All right. Or alternatively, there is the heat of vaporization. That's the energy it takes to turn substance from a liquid into a gas. It's unique for every substance, and just like specific heat, it's something you can look up. So let's take a look at question number 9 again. Question number 9, not this one, not this one. Oh, this one. Sorry, I had like 50 billion windows I needed to close. All right, back to number 9. So how much energy do you need to melt 1,402 grams of ice? So going back to this equation, we are trying to solve for the energy. We know the mass is 1,402 grams. Now, what is the heat of fusion here for ice? What is the energy it takes to melt a gram of ice? Well, we can just go over here. All right, and I've included this in the document. If you don't see this information, highlight column O and change the background to white. And it says here that the heat of fusion for ice is 334 joules per gram. Ice takes 334 joules to melt a single gram of ice. So the energy to melt 1,402 grams of ice is just 1,402 times 334. And the answer I got is 468,268 joules. Okay, I'm going to plug that into my equation and see if I got it right. I'm going to plug it in right here. So we've got 468,268 joules. That is correct. That's how much energy it takes to melt 1,402 grams of ice, or approximately the energy contained in 9 Oreo cookies. All right, now on to problem 11. If you have 389,000 joules of energy, what mass of gold could it melt? Now we're using the same equation, all right? The energy it takes to change something's phase is equal to its mass times the heat of phase change, all right? So let's take a look at what this problem is giving us. It wants to know what mass of gold. So we are solving for mass, all right? It gives us the energy, 389,000 joules, and we know the heat of fusion of gold. It doesn't tell us in the problem, but if we go over here, we see that gold has a heat of fusion of 64 joules per gram. It takes 64 joules to melt a single gram of gold. And now we solve. This is going to take a little bit of algebra. All right. We want to solve for mass as being multiplied by 64, so we need to divide both sides by 64. The mass of gold that can be melted with this much energy is equal to, let's see here, this is an extra zero there, 389,000 divided by 64. The answer I got is you could melt 6,000 6,078 grams of gold with that much energy. I'm going to plug it in and see if that is correct. All right, let's see here. La 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 la. 6,070. Oopsie, wrong field, Gucci. Put it down here. All right, here we go. 6,078 joules. And it's correct. All right, very good. So there you go, guys. That's how you do from your homework problems number 9 and 11. 10 is similar to 9, and 12 is similar to 11. Thank you.